Hi, my name's Nav Gupta and I'm an Aero FAE. I support Intel's FPGA products. I think my Agilex development board came. What was in the box that came today. It's the latest Intel Agilex development kit. We'll take a look at what's inside the box a little later. This presentation is an introduction to Intel's Agilex 10nm SuperFin FPGAs that are taking FPGA performance to the next level. This module is the first part of the Aero Intel Agilex FPGA Design Seminar Series. Let's go over what we will cover in today's presentation. We will look at the Agilex architecture to see what drives its performance. We start by looking at Intel's FPGA portfolio, do a quick Stratix 10 refresher, look at Agilex performance and power advantages, and some of the Agilex fabric innovations. Then we will look at Agilex family variants and transceiver tiles to help you understand how do you choose what to use. And finally, we'll look at Agilex design and where to start. I'll touch on the development kits, like the one I got, and point you to additional resources like additional seminars and Agilex collateral so we can get the conversation started. Let's do an Intel FPGA portfolio overview and a Stratix 10 refresher. So here is Intel's FPGA portfolio today. The portfolio consists of several different FPGA families, each optimized for a different segment of the market. Moving from left to right across the slide, Max 10 FPGAs are non-volatile and are the smallest FPGAs in the portfolio. They are the lowest cost, lowest power devices. Cyclone 10 FPGAs are best suited for cost-sensitive, low-power applications that need more performance than is available from Max 10. 20nm Aria-10 FPGAs are mid-range devices with a blend of high performance and low power features that service applications that lie between the high-end FPGAs and the low-cost FPGAs. 14nm Stratix 10 devices are Intel's highest performance FPGAs in production today. These devices are intended for the most demanding state-of-the-art high-performance applications. And Agilex is Intel's next-generation high-performance 10nm SuperFin FPGAs, optimizes for data-centric applications and delivering significant performance gains and power reduction compared to Stratix 10. The thing to note here is that 10nm SuperFin process, which Agilex is built on, is an optimized 10nm process that delivers the benefits of a full process node versus the first Intel 10nm process. It's the same technology as Intel's new Tiger Lake family. Together, Intel has a comprehensive portfolio for every application. Let's do a quick Stratix 10 refresher. So what's under the hood of a Stratix 10 package? From this actual photograph of the Stratix 10 device, you can see it's a tiled architecture. On the left is a Stratix 10 TX device with a combination of E tiles and H tiles connected to the left and right sides of the fabric die. On the right is a Stratix 10 MX device with embedded HBM memory attached to the top and bottom edges of the fabric die and transceiver tiles connected on the sides. This Stratix 10 innovation was to put the transceivers on separate tiles instead of integrating them on the main die. The transceiver tiles are connected to the main die using Intel's EMIB packaging technology. This approach has several advantages. It allows the use of different process technology for the transceiver tiles and the fabric die. It allows reuse of the tiles across multiple product families, and it allows combinations of different tiles to be used to meet specific market needs. Agilex also uses transceiver tiles and EMIB. Several of the tiles are reused from Stratix 10 and others are designed specifically for Agilex. The other major innovation in Stratix 10 was its HyperFlex core architecture. This innovation was adding millions of registers, hyperregisters, to the interconnect routing on the device. It was driven by the need to mitigate the overall delay that was being dominated by the interconnect rather than the logic delays. As transistors continue to shrink and get faster, This is especially true in FPGAs where there is so much interconnect routing in the core fabric and the device. Circuits can be retimed using these hyperregisters in place of ALM registers and as pipeline stages within the interconnect. And what's cool is the retiming and pipelining is done automatically after the design has been fitted, so multiple design iterations are not required. Agilex goes further and uses an improved second-generation HyperFlex architecture.
Well, let's talk about Intel's new Agilex FPGAs and see what makes them great at processing, storing, and then moving data.
In the quest to process data at higher speeds and with greater power efficiency, Agilex is based on an improved second-generation HyperFlex architecture to deliver up to 40% higher performance or up to 40% lower power compared to prior generation FPGAs. And due to the enhancements in the DSP block architecture with new DSP number formats added to support artificial intelligence applications, Agilex can also deliver up to 40 teraflops of floating point performance. In terms of data storage, Agilex FPGAs will support the most advanced memories, including DDR5 and high bandwidth memory. Agilex also supports Intel Optane persistent memory. As for moving data, Agilex FPGAs support CXL, coherent interface to Xeon processors, and PCI Express Gen 5, providing the highest bandwidth for processor communication. Agilex also supports up to 116 gigabits per second transceiver data rates. With all these capabilities, Agilex FPGAs are ideal for applications in many areas. Let's look at Agilex power and performance advantages.
Look, it's all about performance. Let's see what drives Agilex's performance.
Agilex derives its performance from a combination of Intel 10nm SuperFin technology optimized specifically for Agilex, improved second-generation HyperFlex architecture, improved ALM or adaptive logic module, improved routing, and restructured fabric floor plan, and enhancements to Portus to take advantage of the hardware improvements. Combined, this gives up to 40% higher performance for Agilex compared to Stratix 10. Across 54 representative designs in our Quality of Results benchmark suite that covered a wide range of applications, Agilex is demonstrating push-button performance improvement of 40% on average compared to Stratix 10. This is a huge step forward in performance for Agilex. We saw earlier that Intel's 10nm SuperFin process has optimizations to benefit Agilex performance. There are also process optimizations that specifically benefit Agilex power. Transistor types are tuned so that high-performance transistors and low-leakage transistors are both available in Agilex. This gives high performance where needed in the fabric and reduces leakage power in other areas of the circuit where high performance is not required. The configuration memory is a good example of this. Also, the metal stack is optimized for Agilex to reduce capacitance in the metal layers, improving performance and reducing power. This is especially important for FPGAs because of the large amount of metal interconnect routing. Power is further reduced by the availability of Agilex devices that run at lower power supply voltage and have additional power bins compared to previous generation devices. Here are 6 examples of typical designs across different applications implemented in both Stratix 10 and Agilex. Stratix 10 is shown in dark blue, Agilex in lighter blue. For each design, the power is normalized to Stratix 10. In running these designs, Agilex is delivering up to 40% lower power than Stratix 10.
Let's move on and look at some of the fabric enhancements in Agilex, like the tile architecture improvements and the enhanced hardware features.
In Stratix 10, the rectangular sector array is disrupted by the STM, HPS, and ESRAM blocks that are located inside the array. If the user's design requires routing across these blocks, there is an impact on timing due to the length of the wires to cross the blocks. Also, in Stratix 10, the general-purpose I/O cells and external memory interfaces are arranged in columns that are distributed throughout the sector array. And again, timing of the user's design is impacted by the length of the wires to cross these columns. To improve performance, the Agilex floor plan has been reconstructed to remove disruptions from the sector array in the middle of the device that contains the logic cells, M20K and DSP blocks, row and column interconnect routing, and the clock routing. The Agilex floor plan moves blocks into the corners of the die where they are not disruptive to the sector array. The SDM is moved to the lower left corner, the HPS moved to the upper right, and the embedded SRAM blocks occupy the other two corners. Also in Agilex, the GPIO cells and external memory interfaces are moved to the top and bottom edges of the die. The result of removing these disruptions from the sector array is consistent and predictable timing in Agilex, leading to higher performance. And like Stratix 10, the transceiver tiles are connected to the sides of the die using Intel EMIB technology. As mentioned earlier, Agilex uses a second-generation HyperFlex core architecture. In Agilex, several improvements have been made to HyperFlex to increase its performance and reduce power. The hyper registers have been redesigned for performance, and power gating is used to ensure that unused circuits are completely powered down. Let's take a quick look at some Agilex hardware features. In Agilex F-Series and I-Series devices, hard memory controllers capable of supporting DDR4 up to 3200 megabits per second. DDR5 and Intel Optane persistent memory will be supported by the M-Series devices. The memory control in Agilex is similar to Stratix 10, except it will support a span of 72 bits maximum. In Agilex, the I/O buffer is optimized for high-speed external memory interfacing, leading to a lower supply voltage. So single-ended voltage reference I/O standards are limited to 1.2 volt maximum. Supply voltage and true differential I/O standards are limited to 1.5 maximum. On the DSP support front, Agilex has added half-precision floating point support, which is ideal for many floating point operations that do not require single precision, including some machine learning and convolutional neural network applications for image and object detection. Half precision also consumes 50% lower power compared to single precision. Agilex has also increased the number of 9x9 multipliers that can be implemented in a single DSP block. In Stratix 10, there are 2 9x9 multipliers per block. In Agilex, there are 4. Agilex high-end devices have increased DSP block density compared to Stratix 10. That leads to 2x or 5x increase in the amount of fixed point multiplier resources compared to Stratix 10, depending on which multiplier precision you need. Like Stratix 10, Agilex device security is managed by a triple redundant processor known as the Secure Device Manager, or SDM. It also manages configuration and instead of a hard-coded finite state machine. In addition to handling encrypted bit streams and security keys, the SDM manages the anti-tamper sensors, secure boot support, and multi-factor authentication as well. Since the SDM is software-based, it provides flexibility and can adapt to new security breaching techniques as they evolve.
So the Agilex family has several different family variants and several different transceiver tiles. So let's take a quick look at this.
3 different variants make up the Agilex family today. The F-Series devices are intended for a wide range of general-purpose FPGA applications and include a variety of different tile combinations. These devices have up to 58 gigabits per second PAM4 transceivers, PCI Express Gen 4 support, and an optional quad-core ARM Cortex-A53 processor. You can think of the F-Series as being the flexible series. The I-Series devices have higher speed transceivers, up to 116 gigabits per second PAM4, PCIe Gen 5, and CXL support. And all I-Series devices contain a quad-core A53 processor. You can think of the I-Series as being targeted for high-speed interfaces. The M-Series devices, which are still in the roadmap stage, are intended for high-performance memory applications and include a number of devices with HBM memory connected to the FPGA inside the package. These devices also support higher speed external memory interfaces such as DDR5 and also support Intel Optane persistent memory.
Let's take a quick look at the transceiver tiles in the Agilex family.
This slide shows the transceiver tiles used in Agilex. The name of each tile is at the top of the table, followed by the number of channels and maximum data rate specification for each tile. Below are the details about the hard IP protocol support on the tile. The tiles are organized into two groups on the slide. The first group is the network and communication tiles. These are general purpose tiles, and in addition to the hard IP shown in the table, these tiles support a wide range of protocols using soft IP. The second group is the process attached tiles. These are not general purpose tiles, they are designed to support specific protocols. The P tiles only support PCI Express, and the R tiles only support PCI Express or CXL. Three of the tiles, H, E, and P, are already in production today with Stratix 10 and will also be used in Agilex. The two additional tiles, F and R, are not available in Stratix 10 and are newly designed for Agilex. The next slides will go into a few details about each of these transceiver tiles. The H tile is a general purpose tile with 24 transceivers running up to 28 gigabits per second and has PCIe Gen 3 and 50 gigabit and 100 gigabit Ethernet, and soft IP is used for other protocols. The E tile is also a general purpose tile with 24 transceivers running up to 58 gigabits per second, has 10 gigabit, 25 gigabit, and 100 gigabit Ethernet flexible MAC options, and soft IP is used for other protocols. The F tile has transceivers that can operate up to 116 gigabits per second and supports up to 400 gigabit Ethernet and PCIe Gen 4 with bifurcation options. The P tile provides hard IP support for PCIe Express Gen 4 up to by 16 wide, either as endpoint or root port. Note, the P tile can only be used for PCI Express. It cannot be used to support any other protocols. The R tile supports PCI Express Gen 5 or CXL. It supports PCI Express Gen 5 interfaces up to by 16 wide, either as an endpoint or a root port. The R tile supports the CXL interface to Xeon processors for the purpose of cache coherent acceleration. Make sure to click on the resource link at the end of this presentation if you would like more details and information on the Agilex transceiver tile architectures. The Agilex devices will come with several tile combinations. This and the next slide show the combination of Agilex F-Series devices. Note that Agilex M-Series devices are still on the roadmap stage. The devices on the slide offer a combination of E and P tiles and a combination of H and P tiles. Both the E tile and the H tile support a wide range of protocols. The devices shown here are all based on F tile and contain 1, 2, or 4 tiles. The F tile is also capable of supporting many different protocols. This slide shows the Agilex I-Series devices featuring combinations of R tiles and F tiles. The F tile is a general purpose tile supporting many different protocols, while the R tile supports either PCI Express or CXL.
Let's compare Agilex to Stratix 10 and Aria 10 to give you an idea on how to choose what to use.
As Agilex devices roll out over the next several quarters, keep in mind that there are over 50 different Stratix 10 devices available in production today. While Agilex is delivering significant performance gains and power reduction compared to Stratix 10, there are cases where Stratix 10 may still be the best choice. This slide compares the various benefits of Stratix 10 versus Agilex to make it easier to understand the strengths of each family. From a design reuse perspective, you can go to production today with Stratix 10 and easily move your design to Agilex in the future. Both device families are based on a HyperFlex architecture. Both are available with the same quad-core ARM Cortex-A53 processor, and both have advanced security capabilities. An investment made today in Stratix 10 can be extended to the future with Agilex, and you will benefit from the high performance and lower power of the Agilex devices when you make that transition. Most high-end FPGA designs take advantage of the high-speed transceivers on the device. Stratix 10 offers a higher number of 28 gigabits per second transceivers than Agilex. On the other hand, Agilex transceivers can reach higher data rates, all the way up to 116 gigabits per second. Looking at the hard IP that supports the transceivers, PCI Express Gen 4 and 100 gigabit Ethernet hard IP is available on Stratix 10. However, the new transceiver tiles that are being designed specifically Agilex have additional hard IP, such as PCI Express Gen 5 on the R tile and 400 gigabit Ethernet on the F tile. that are not available in Stratix 10. General purpose I/O interfaces and external memory interfaces have more flexibility in Stratix 10, allowing a wider range of operating voltages, all the way up to 3 volts in some devices. In Agilex, the I/O voltage range is limited to lower voltages, but this allows higher speed operation, and as a result, Agilex supports faster DDR4 memory speeds. Also note that Stratix 10 devices within package HBM memory are available in production today, whereas Agilex HBM devices are still at product roadmap stage. Finally, for DSP-intensive compute and AI applications, both devices offer hardened fixed point and hardened floating point DSP blocks. However, to better address AI applications, Agilex adds several new DSP formats such as bfloat16, FP19, FP16, and int9 that are optimized for AI applications that are not available in the standard Stratix 10 DSP block. Remember, you can go to production today with Stratix 10 FPGAs and extend your investment with next generation Intel Agilex FPGAs. Here are some options of how some Stratix 10 devices map to Agilex family variants. If you're considering moving from ARIA 10 devices to Agilex devices, you may want to consider the F-Series Agilex devices and the following Agilex advantages. Agilex devices have advanced performance both from a technology and architecture perspective. 10nm SuperFin HyperFlex architecture and quad-core ARM A53 architecture. Agilex transceivers can reach higher data rates than what are available in ARIA 10, up to 58 gigabits per second, and hard PCIe Gen 4 support in F-Series Agilex devices. Agilex supports faster DDR4 memory speeds than ARIA 10. ARIA 10 has fewer DSP formats compared to Agilex. Move to Agilex F-Series devices to next generation Stratix 10 or Agilex devices to harness the higher performance you need. Here are some options on how the ARIA 10 device families map to the Agilex family variants. You can see if you need the performance, then moving from ARIA 10 to Agilex F-Series devices makes perfect sense.
So let's take a little bit closer look at the development kits that Intel has to offer for the Agilex FPGAs. So this is the development kit I received from Intel. This is the F-Series Agilex transceiver development kit, and as you can see, it's really nice because it's got this small fan that cools it. It doesn't have the big liquid-cooled cooling system on it, which I really like. The form factor is great. It's got all the SMAs and the PCIe Gen 4x16. It's got, on-chip DRAM. It's got this MXP transceiver connector, a SODIMM interface. It's got a host of things. I really like this development kit.
2 Agilex F-Series development kits are available today. Here's the one I got, the Agilex F-Series transceiver SoC kit. The board is assembled with an Agilex F-Series device that contains the optional hard processor system. Several of the transceiver channels are connected to high-speed connectors to allow evaluation of transceiver signal integrity and allow cabling of the transceivers to another board for system evaluation. The board also has chipped down 8 gigabit DDR4 memory and a SODIMM connector. Notice the device rectangular package. This can help reduce the number of circuit board layers required to break out memory-intensive designs and can also make component placement easier in form factor constrained applications like PCI Express cards. The Agilex package plan consists mainly of rectangular packages, but some of the small Agilex packages are still square. Here's the other kit. It's a full-height, 3/4 length, 2-slot PCI Express form factor board with Gen 4x16 edge connector. The board is also assembled with an Agilex F-Series device that contains the optional HPS hard processor system. The board also contains 2 QSFP DD cages and 4 DDR4 DIMM connectors. My colleague Sebastian has one of these, and you will probably see it in his presentation, which is part of this seminar series.
With all its architectural and process innovations, the Intel Agilex 10nm SuperFin FPGA family is taking performance to the next level, with up to 40% faster performance or up to 40% less power compared to 14nm Stratix 10 FPGAs. In addition, the Intel Agilex family devices have advanced hardware features and transceiver tiles. This, combined with innovations in the design tools, make Intel Agilex devices perfect for your next higher performance design. So where do you go from here? For more information on Agilex FPGAs, make sure you watch the other Arrow Agilex videos in this seminar series. To get started with more information and resources, please visit the links available in the green folder icon at the bottom of your console. And finally, please remember to always feel free to reach out directly to your local Arrow salesperson or your local Arrow FA. Again, my name is Nav Gupta. Thank you so much for watching this presentation.